welcome back to the channel, and in today's video I will introduce you to the non-inverting amplifier. So this is a series that kind of follows on from the first video I did about operational amplifiers, where I covered the basics and the inverting amplifier. So let's just start by drawing the non-inverting amplifier circuit. Here we have the input voltage, Vin. And because this is the non-inverting amplifier, we connect the input voltage to the non-inverting terminal, just like this. Okay, and now we have the inverting terminal here with two resistors that act as a voltage divider. So we'll call this the ground resistor, RG. And we'll call this the feedback resistor, RF. And this is the output voltage, Vout, of the non-inverting amplifier. So what we're looking for here in this case is an equation for the closed loop voltage gain, AV, which is equal to Vout over Vin. Just like that. That's what we're looking for. So what we will do is kind of redraw this area of the non-inverting amplifier to achieve this expression. So this is a typical voltage divider, but this time we have the Vout acts as the voltage rail. Here we have RG, and this is RF. And at the output here of the classical voltage divider, we have the input voltage that will be fed in from the non-inverting terminal. If you're not sure how this happens, how this input voltage gets matched to the inverting terminal like that, I suggest you watch my first video again, where I cover the basic rules of the operational amplifier's behavior. And I also suggest you watch the video I did on the voltage divider circuit, so that you can better understand where I get this following equation from, which I'm about to show you. So we're looking for Vout over Vin. In this case, we have Vin equals Vout multiplied by RG over RF plus RG like this. And we're arranging for it like this, Vout over Vin. So we will rearrange like so. We will do Vout over Vin. So to fully explain what I'm doing here, divide both sides by Vin, multiply both sides by RF plus RG, then divide both sides by RG. So we end up with this. Okay, then we can simplify this a bit further to make it more general and simple. So what we can do here is kind of split this denominator like this. Okay, so by taking a closer look at this part, we can see that RG over RG is just going to be 1 every time. So we can finally say that the closed loop voltage gain, AV, is equal to RF divided by RG plus 1. And that's true every time for the non-inverting amplifier's most basic configuration here. Okay? So this covers a lot of the basic analysis of the non-inverting amplifier. So now I'll just have a couple of questions to test your knowledge on this circuit. So we'll just cut to that. Okay, so here I have 3 questions for you to try. So question 1, I want you to find the value of the ground resistor here, RG, when the closed loop voltage gain is equal to 11 and the feedback resistor has a value of 7 kiloohms. And for question 2, I want you to try and use Ohm's law, that's a hint, to permit a current of 20 milliamps and a voltage of 4 volts to flow through this voltage divider of R1 and R2 here. So let V in equal to 6 volts here as well. And for the last question, question 3, I want you to find out the output voltage V out when you have the input voltage here and the closed loop voltage gain here. Okay, so that's all for these questions. I want you to have a go, of course, and I'll run through the answers with you in just a second. So let's start with question 1. We would like to rearrange for RG, which is equal to RF divided by AV minus 1. So let this be 7 kiloohms divided by 11 minus 1, which is 10. So the answer here is 700 ohms for RG. And now for question 2. So what you should be doing here is trying to find values of R1 and R2 using Ohm's law. So we'll start with R2. So R2, this marker is kind of running low. So R2 also has the voltage at the output of the voltage divider here, which is 4 volts. And we divide that, of course, by the current to get the resistance. So 20 milliamps gives a value of 200 ohms. And since we've chosen the input voltage here to be 6 volts, and we have 4 volts going across R2, of course 2 volts would then have to go across R1. So I'll draw it here. R1 is equal to 6 minus 4 over 20 milliamps. Of course, these are volts. Gives a value of 100 ohms. Okay, and for the last question, we want to find the output voltage. So we have V in here is 4 volts multiplied by the closed loop gain of 11 gives us an output voltage of course 44 volts. So these are the questions, all 3 of them completed. So I hope you enjoyed these questions and learned something a little new about the non-inverting amplifier. That's all I have for today's video. Thank you very much for watching.